Hello and good morning to everyone. My name is Mark Robles, MIS student of UP Open University. In this video, I am going to answer the question in our discussion number 2. The question is, describe the need of concurrency within the framework of an operating system. To answer this question, let's first define concurrency in an operating system. Concurrency is a property of systems in which several processes are executing simultaneously and potentially interacting with each other. In an operating system, this happens when there are several process threads running in parallel. These threads will communicate with each other through either shared memory or message passing. In a real-world definition, concurrency is really whenever you have multiple things happening at the same time that interacts. Some of the real-world examples of concurrency are railway network, banking systems, shared bathroom, traffic lights, and shared streets. In this video, I'm going to explain the concurrency in a traffic light and shared street situation. Concurrency in a traffic light and shared street situation. In this example, we have a problem. We have shared resources, which is the intersection that cars in both directions want to go through. How do we make sure that cars don't collide? We have rules, and some cities have traffic lights that tells us which direction cars are allowed to go. The rule is don't enter the intersection if the light is red or yellow. And when the light changes to green in your direction, wait for all the cars in the intersection to exit. If you follow these rules, then it's safe for both directions in the intersection and there won't be any collisions. In the same way, operating systems should apply concurrency to avoid collisions when several processes or instructions are accessing the same shared resources. This will also enable efficient use of shared resources within an operating system. This diagram shows a very basic example of concurrency in the operating system. Suppose that there are 3 processes, namely 1, 2, and 3. All 3 of them are concurrently executing and they need to share a common resource as shown in the diagram. Synchronization should be used here to avoid any conflicts for accessing this shared resource. Hence, when process 1 and 2 both try to access that resource, it should be assigned to only one process at a time. If it is assigned to process 1, the other process, which is process 2, needs to wait until process 1 frees that resource. Why concurrency is important in an operating system? Concurrency is important in an operating system to optimize the use of time, because the processor performs instructions at a rate thousands of times faster than external devices and millions of times faster than human beings respond. Concurrent processing optimizes the use of time the processor by eliminating idle time in the processor. Concurrency is also important to reduce the available time for other processes through the process called batch tasks. Rather than running one program multiple times to process one transaction each time, batch processes will run the program only once for many transactions, reducing systems overhead. The operating system needs to decide which processes runs at a certain point in time, and in order to accomplish this, the operating system needs to implement concurrency through process scheduling. Scheduling also selects which running process to pause or which process to move to the back of the queue and start the new process. This is all my presentation for today. Thank you and have a great day, everyone.